Okay, so today we are actually on a small island near Fyn called Tunø, which means Tuna Island. And what's really characteristic about this island and a lot of the smaller Danish islands is all of the rocks we see on the surface are actual glacial deposits, which have brought a lot of foreign rocks to this island. And I've found quite a different types of these foreign rocks here on Tunø, and I've displayed them here in front of us. And as you can perhaps see from a distance, we have our three main rock types represented. So these three rocks over here are different types of sedimentary rocks. Then we have different types of metamorphic rocks here in the center. And finally we have two different specimens of igneous rocks here to the side. And what's really interesting is most of these rocks are actually not native to Denmark. But we can actually identify where the ice came from based on where these different rock types occur in the different bedrock localities of, for example, Norway and Sweden. So, first off, here to the side, we have a piece of chert, which is typically occurs in like chalk and different types of limestones, and we have a lot of this in Denmark. So this is likely a Danish rock. Here to the side we have a sandstone, and you can kind of tell how the sand layering actually kind of fans. And this rock is typical of southernmost Sweden and the island of Bornholm. So it was likely transported here during one of the youngest ice sheets that covered this area. Then we have this grey rock here, which is a mixture between a limestone and a shale, so we typically call this a marl, and it's relatively carbonate rich but still contains a lot of sand and clay particles. And that's our sedimentary rocks. Then we have the different metamorphic rocks on this beach stretch. So we have here the first three rocks are actually the same overall type of metamorphic rock called a gneiss. But as you can see, they differ quite a lot in appearance, and that partially has to do with the pressure and temperature conditions they were under, and also has to do with the type of rock they were before they became more metamorphosed. So whether we get this kind of layering or like a very weak layering orientation, as we can see in this one, all these huge crystals in a quite old layered rock as well. Finally, we have this big, sparkly, dark one, and all of the sparkly surfaces are amphibole crystal surfaces. And if you look closely, you can see small red crystals in between, and those are garnets. So this is what we would call amphibolite. Then, finally, we have our two igneous rocks. So the dark one here to the side is a basalt. And it's quite rich in iron, so it's quite heavy, and occurs, it's like a solidified lava, a very primitive solidified lava. And this one, I'm hoping you can recognize, it's a granite. It's been weathered a bit, so you can see it has small holes in the surface where the darker minerals such as amphibole and biotite used to be. And you have the pink surfaces that are feldspars, and the very light grey areas, which are quartz crystals. Another thing we can tell from these rocks are just normal geological processes such as metamorphism. Because as I mentioned, both of these rocks, the gneiss and the amphibolite, are metamorphic rocks, and they are actually in approximately the same pressure and temperature range. So if only the temperature and the pressure determined how the metamorphic rock would look, these should be the same, and clearly they're not, right? And that has to do with the type of rock that formed these before they were exposed to higher temperatures and pressures during metamorphism. And generally, when we have a gneiss that looks like this, it has like a weak foliation, we would call it, but still a lot of lighter areas. That's mainly feldspars and quartz. We would say the most likely source rock for this gneiss actually is a granite, because it has most of the same components. The composition is overall preserved, but it just gets this metamorphic texture where we see the orientation of the darker minerals to form a perpendicular strike to the pressure direction. So the pressure direction in this case would have been from this direction. On the other hand, the amphibolite has a much higher iron content. So it was formed by a different type of rock, which could be something like this basalt. So basalts are less evolved lavas, so they have much higher concentrations of iron and magnesium, which means they stabilize different types of mineral phases. So if we expose a basalt to high temperature and high pressure conditions, the more iron-rich composition will result in recrystallization to form lots of these amphibole crystals that are kind of sparkling. And these red garnets, that's likely a type of garnet called almandine, which is also an iron-rich garnet. So you can see the small red crystals here, actually garnet crystals of almandine. The chert and this sandstone here and the marl would likely be from Denmark, for example on the island of Bornholm, or they could be transported from southern Sweden. But these rocks here, the metamorphic rocks we have and the two igneous rocks, we don't find them in Denmark. It's not at the surface here, but these rocks commonly occur in Sweden and in Norway. And based on the types here, I would say it's most likely that these rocks are actually from Sweden. So we have this red gneiss and the two grey gneisses and the red granite, which are very often found in Sweden around the Gothenburg area, so on the west coast or relatively close to the Norwegian border. And then we have this big amphibolite, which is often linked to the latest mountain range formation in Norway and Sweden called the Caledonian Mountains, where we got high-grade metamorphism and a lot of relatively primitive rocks that were metamorphosed to form these amphibolites, and we find them on the border between Norway and Sweden. So based on that, it's very likely these rocks were all transported here to Tunø beach in one of the ice sheets that came from central Sweden, and typically that's ice sheet is stated to have arrived in Denmark around 20 to 22,000 years ago. So that was a quick look on some of the beach rocks we can find here on Tunø. I hope that it encouraged you to go check out the rocks on your local beaches as well and experience what local stories just the rocks can tell you about the nature and the area you're living in. And remember, if you want to check out more, go down and check some of the links in the description, and I also have references to literature there if you are interested or curious to learn more about geology or beach rocks.